Today we're going to look at trigonometric functions, and we're going to look at how to graph them and the characteristics of their graph, continuing on our functions unit. So we'll define our trigonometric functions, and then we're going to look at their different characteristics, and then look at their overall graphs. So let's look at our definitions. We have our sine function and our cosine function, and what's important to note is whenever we're dealing with sine and cosine and tangent functions, our angles, we're going to be measuring them in radians. So remember, radians have to do with pi, so we're no longer dealing with angles. Everything should be in radians. So if you're using your calculator for any of these problems, make sure that you're in radian mode and not in degree mode. And here's the tangent function definition as well. So first, let's just talk about set of ordered pairs. Like, let's say if we wanted to graph just by graphing some set of ordered pairs. The domain, these are x values. So if we were to plug in 0.1745 for x, y equals sine of 0.1745. If we evaluated that in our calculator, we would get approximately 0.1736. If we were to plug in our next x value in our domain, we would get 0.3746. And then our last x value that they give us in our domain gives us that. So our set of ordered pairs is this set right here. So if we were to plot those points and look at this graph, we would get something that looked like this. So notice this is a periodic function, because if you notice, our graph starts over after 2 pi. So this is the general graph of a sine function. Notice that it starts at the origin, goes up to 1, comes down at x equals pi, and then goes all the way down to -1, and then decides to go back up. And it takes 2 pi to finish the entire cycle. So the sine function has a domain of all real numbers. However, if you notice the graph, it went up to 1 and then went down to -1, then went back up to 1. So our range is only between -1 and 1. It has a period of 2 pi because that's when the cycle starts over again. Let's take a look at our graph of our cosine function. It looks like this. So it starts at 0, 1, it goes down to -1, and then it goes back to 1. And it takes, for the period, for one cycle, it takes 2 pi, just like the sine function. So for cosine, your domain is all real numbers, range is -1, 1, period is 2 pi, very similar to the sine function. The only difference is that the cosine is actually going to start at 0, 1 instead of at the origin. Our tangent function is a little different, because if we were to plot these points, and if we were to plug in pi over 2 and 3 pi over 2 for x into our tangent function, we would get an error. And that is because there are asymptotes at pi over 2 and 3 pi over 2. And in fact, every pi over 2 plus however many pi's, like it repeats every pi or every k pi, you're going to get an asymptote. So our graph looks like this. It's approaching this left-hand bound asymptote, and it goes through at a multiple of pi. That's where it's going to cross our x-axis, and then it's going to approach the next asymptote. So that's the general look, and then that repeats every time. And then we do have those vertical asymptotes. So notice that the cycle of our tangent function is between pi over 2 and 3 pi over 2, which is just pi. So our cycle repeats every pi times with an asymptote in between. So our domain is a little weird because we do have those asymptotes. So remember, our domain can be all real numbers except for pi over 2 and plus any multiple of pi. So every pi you're going to have another asymptote starting at pi over 2. And our range, however, is all real numbers because our y value can go down and up, approaching those asymptotes. And our period is a little shorter. In between asymptotes, you have a period of 1 pi, and then it repeats the cycle again. So let's talk about another definition. We have this word called amplitude. The amplitude is the absolute value of half the difference between the maximum and minimum values of the function. So if you're looking at sine and cosine, those maximum minimums for the general graph is 1 and -1. So that's what they're talking about when they say the maximum and minimum values. They're talking about how far up and how far down. So you subtract those two values, you divide it by 2, and you take the absolute value, and that gives you what's called your amplitude. And you're like, well, it's kind of obvious from the graph what the amplitude is. However, when your graph starts to shift up and down, it's going to be a little bit difficult to determine the amplitude, and that's why we have this formula. So let's take a look at our sine function and how to calculate using the formula. So our 2 minimum and maximum is 1 and minus -1. And 1 minus -1 is 2. Divided by 2 is 1. And the absolute value of 1 is 1. So we have an amplitude of 1 for our sine function. So if we were to look at just our general function of the sine function, amplitude is going to appear right before your actual trig function. Usually we're going to represent it with an A for amplitude, and so if we want to know what the amplitude is, we can look in front of our trig function. So notice that the graph of f of x equals sine of x, it doesn't have a number in front of it. It doesn't have an A value, unless you consider, well, there's technically a 1 in front of sine of x, because 1 times sine of x is just sine of x, which makes sense since the amplitude of f of x equals sine of x, we just calculated to be 1. So amplitude is the absolute value of A. So if we had a negative A, the amplitude is still the same. The negative actually is going to flip it across. It's going to reflect your graph across the x-axis. So let's say we wanted to graph 2 sine of theta. So here's sine of theta right now. So remember we looked at this graph earlier, and if our amplitude is 2 instead of 1, what's going to happen is our graph has to go all the way up to 2 and then go all the way down to -2. So that's 2 sine of theta. So this is our general form of the sine function and cosine and tangent. So notice that they all look very similar. Notice that there's an n value and a b value. So we're going to look at what those values do and how they translate our functions. We have what's called the period of a function. So we talked about periodic functions in our last lesson, and so it is the length of a cycle for the values of a periodic function. So sine and cosine, if we want to figure out what our period is, we're going to take 2 pi, which is, remember that's the period of our parent functions, y equals sine of x or y equals cosine. So if we have an n value, then what we would have to do to figure out our period is take 2 pi and divide it by the absolute value of n. And so n is the coefficient in front of theta in our equation. So remember those general forms of equations that were on that previous slide? The coefficient in front of theta, which we represented with an n, that's what we're going to divide 2 pi by, and that's how we're going to figure out what our period is. So tangent is a little different because tangent has in general, f of x equals tangent theta. The period of that function is pi. So if we want to know what the period of tangent is when we have an n value, we have to do pi divided by the absolute value of n. So let's graph y equals cosine 2 theta. So we have an n value. This is our graph of y equals cosine theta that we looked at. So this is the parent function, our parent graph. And if we have 2 theta, that means we have to calculate a new period. So we will do 2 pi divided by 2, which is pi, which means that instead of our cycle going from 0 to 2 pi, it's going to go from 0 to pi. So it has to make this journey in pi. So it has to make this journey. So it's basically going to shrink. So it's going to look like this, y equals cosine 2 theta. So notice that it starts at the same spot, but instead of getting to go all the way here, it has to go here because it has to go back up before it reaches pi. We also have something called a phase shift, and to calculate the phase shift, we have to take our b value and divide it by n. So notice that in your general function, it was minus b, right? So minus b will move right, plus b will move left, and you have to divide it by n, which is the number that appears in front of theta. So let's do cosine theta minus pi. So our n value is 1. So we had to do pi divided by 1. So, and it is a minus pi. So that means we're going to move to the right pi. So remember, it starts here. Our parent function started here. So we have to move, we have to shift to the right 1 and then start our graph. So it will look like that. Okay, so when y equals a sine of n theta minus b, or y equals so these are our parent functions, or our general functions. So these general functions do translations. So the amplitude, or the a value, shrinks or stretches our graph vertically. Our period, which is the 2 pi divided by n for sine and cosine, is going to stretch or shrink the graph horizontally. And then our phase shift, which is b divided by n, moves our graph left or right. So let's graph y equals negative 1 over 2 sine of 2 theta minus pi. So there's all kinds of translations going on. So this is our parent function. And so this negative 1/2 is going to shrink our graph, okay, because our amplitude is now negative 1/2 instead of 1. But since it's negative, it's also going to reflect it across the x-axis. So now it looks like that. So now we're here. So now let's do our other translations. We have a 2, which means that we have to do 2 pi divided by 2, which is pi, which means our period is pi. So we have to shrink horizontally to pi, which is what we did here. And now we're going to have to translate left or right because we have a b value. So remember, for our b value, we have to do our b divided by our n. So pi divided by 2. So that means we're going to shift pi over 2. And because it's minus pi over 2, or minus pi, we're going to have to shift to the right to pi over 2. So there's our shift there. So this is our new graph, and we'll go ahead and finish sketching it. So that way we can see what it looks like with several cycles. All right, so that is how you graph trig functions. Go ahead and try some problems on your own.